Welcome to this video, which is giving you just an overview of some of the keys to section 1.3. As you've read in this section, and I'm hoping you've already read this section, some important definitions that you need to know are collinear, non-collinear, and betweenness. Those are on page 18. And things you'll need to understand are the triangle inequality on page 19 and what you can and cannot assume from a diagram. This last one is really important and will be important in everything we learn in the future, because every diagram we look at, you'll have to assume some things, and there are some things that you cannot assume. So what I'd like to do in this video is just go through some examples of collinearity, betweenness, and triangle inequality, just to give you a sense of how these things are applied. So first, let's look at some examples involving collinearity and betweenness. Consider the diagram here. You'll see we have two line segments intersecting. So line segment AB intersects line segment EF at the point M. So let's take a look at this diagram. Question 1 says, are A and B collinear? A and B are collinear because any 2 points can define a line. So any 2 points are collinear. So let's look at question 2. Are E and B collinear? This is a little tricky because you look at it and you don't see any line connecting E and B. However, those 2 points are collinear for the very same reason that any 2 points are collinear. Any 2 points can determine a line. And although we don't see a line between E and B, we could certainly draw one because there could be a line going through those 2 points. Okay? So for number 2, are E and B collinear? The answer is yes. Even though you didn't see a line there, they are collinear. So I'm going to say yes here. Is F between A and B? So remember, the definition for betweenness is F would be between A and B if it is on that line segment and it falls between A and B. That is, it's not beyond A or beyond B. So if we look at this, F is not actually on line segment AB. So F is not between A and B. So we're going to say no. Is M between A and B? Well, let's look at it. M is clearly on the line segment from A to B. So M is between A and B, yes. And finally, is M between A and F? Again, M is not on the line segment AF. Notice that A and F would be collinear. However, M is not on the segment that would be connecting those two. So M is not between A and F. Okay, so let's look at the next slide. This is just an application of the triangle inequality. Okay, LK must be larger than what number? And number 2 says LK must be smaller than what number? So notice this notation, LK. It does not have a line over it. It's not the segment. LK without the line over it represents the length of the segment. So LK must be larger than what number, and LK must be smaller than what number? Well, what the triangle inequality tells us is that any 2 sides, when added together, have to be larger than the third side. So we could generate 3 inequalities from this picture. Okay, we could say JL plus LK must be greater than JK. Okay, that's one, saying that the 2 sides must be greater than the third side. Let's say another one. Let's say LK plus JK must be greater than JL. And finally, JK plus JL is greater than LK. Look at what I've done. I've just listed combinations of the 3 sides. Okay, so 2 at a time. So we've got one here that includes 2 sides, JL and LK. I'm moving around the triangle. Now I'm going to say LK and JK. And finally, JK and JL. So let's look and see what information we can fill in. I know that the length of JL here is 15. So what I'm going to do is in all of these inequalities, replace JL with 15. JL. I'll tidy that up in a sec. JL, I'm going to replace that with 15. Okay, and let me just fix my inequality sign there. Good. Now the other side I know is JK. JK is 7, so I'm going to go in and replace JK with 7. Okay, and we have one more right here in the middle, which is 7. Okay, so let's look and see what we can do with these. All right, I can solve all of these inequalities for LK. All right, so if I solve this one by subtracting 15 from both sides, I'll get LK must be greater than -8. Well, of course it must be, because we can't have a negative side length, so that doesn't really do anything for us. Let's try this next one. LK, I'm going to subtract 7 from both sides, must be greater than 8. Okay, that's helpful. So LK must be greater than 8. And finally, 7 plus 15, so 22 is greater than LK. The other way to say that is LK is less than 22. Okay, so what I'd like you to see here is I've been able to write 3 inequalities based on the triangle inequality, saying that any two sides in sum have to be greater than the third side. I've then plugged in the two side lengths that I know, 15 and 7 for the given sides, and solved each of them to find the constraints on the missing side. So let's look at number 1. LK must be larger than what number? Well, it has to be larger than -8, of course. It has to be larger than 8. So I'm going to say it must be larger than 8. That's the more restrictive of the two. So I want that one, because this guy here is kind of a given. It can't be negative. We know that. Next, LK must be smaller than what number? Okay, well, we look at this and we see LK must be less than 22. LK is less than 22. Okay, so that's an example of applying your triangle inequality. I hope this has been helpful for you, and I'll see you in class.